That should work. All right. What page was the homework on? Oh, man.
44.
How much? 43, 44?
Yeah.
Okay.
It did 19.
Okay. 43 and 44. Oh, before we hit that, is there any of you guys need to finish up on this quiz? Most of you guys are.
I do.
So Jacob, you need to finish this up, okay? And Sawyer, you as well. So can we do it by Friday? Cool. By Friday, sometime on off period. It doesn't matter if you come in here. If I have a class, it doesn't matter if that's your off period or not. You can come in and still make it up. I'll just put you in the back row. Cool. What periods are you off?
4 and 8.
4 and 8. I'm off 4th. 8th period, I'm down the hallway, across the hall. Okay. And you're welcome to come in there. What about you?
4 and 8.
Same thing. So same directions. Cool. Yeah, man. Okay. And you guys aren't pestering my class if you come into an 8th period. Don't think that, oh, I shouldn't go to that because he has a class. Who cares? All right. So 43, 44 was our homework, yes? What kind of questions did we come across?
2.
You said 2? Okay. So I'm going to go, as I go over this, I'm going to phrase this the same way so we can start getting involved. Item 1. Does anyone see an equal sign with this problem? No. No. So I'm not looking for what makes x. I'm not looking for what will make the whole thing 0. So I'm not solving for x. Does that make sense?
Yeah.
So what should I do here? Multiply. So I'm just going to distribute negative 14 over the parentheses here and here. So I get negative 14x minus, and then 14 times 3 is, I believe, 42. Is that right? I think that's right. That's done. There's no further to go. Is that okay, Sophia?
Yes, it is.
Okay. What else did you
7.
see? 7. Number 7. Minus 7. Okay, now these instructions say this. Apply the fundamental theorem of algebra to determine the possible number of roots for the function shown. Okay, this does have an equal sign. Agree? Mm-hmm. But we're not looking for the answers. We're looking to say how many possible answers would be found if we have this. And 3 is correct, but why is 3 correct and not 2? Yeah, my highest exponent up here is 3. So that's my biggest exponent. It doesn't matter where that exponent falls. If this was down here and everything was reversed, it's still my highest exponent in the problem. So this means I have 3 possible solutions. And again, it didn't ask for them. It just said, hey, we have 3 possible solutions. That's it. What else? Yeah.
31.
31. Okay. That one, right? Okay. Ethan, do you see an equal sign up there?
No.
No. So all we have to do to this is factor it. So we're going to break it down. Okay? So let's take a look. Do I have a greatest common factor that's a number?
Yeah, 2.
2. 2 goes in all of them. Agree?
Yes, sir.
Anyone like, where did that 2 come from? Do they all have an x as well? Yeah.
Mm-hmm.
So I can go ahead and factor a 2 and an x out of all 3 terms. So from these, I'm going to bring a 2x out. And then I'm going to rewrite it without this. So realize that's the same thing as this. and this one's the same thing as this. If I broke them down, and this one is the same thing, so I got plus and minus there. That's 2 and 12 and x. And I don't need to break 12 down because all I'm factoring out of all three is 2, correct? So when I go through this problem, I realize, okay, if I factor 2x out of this, what am I left with right there?
2x.
Nope.
1.
X squared, right? There are 2 x's, so x times x is 2x. I'm going to cancel this and this out, so what am I left with there? And then it's positive 11x, right? Plus 11x. Is that okay? And then if I factor a 2 and an x out here, what am I left with there?
12.
Close. Negative 12. Okay. So this is my greatest common factor. So this is going to come down and be part of my answer. So bring this straight down. Okay? Then I want to just go ahead and start factoring this right here. Okay? So my magic number is going to be negative 12. That means I'm multiplying two numbers to get there. So one has to be positive, one has to be negative. What two numbers, one being positive and one being negative, multiply together to give me 12, add together to give me 11. 12 and 1, which one's positive? 12. So positive 12 and negative 1. So negative 12, or 12 times negative 1 is negative 12. Positive 12 minus 1 is 11. So then we're just factoring this. I have an x here minus 1. So what's the rest of my answer?
X plus 12.
Yep.
X minus 1.
X minus 1. Cool. And you remember we brought that original greatest common factor out here. So that's what I got.
Do we do nothing with 3? Oh, never mind. That's 3. Okay. Yeah.
So all I'm doing is I'm taking apart the problems on this one. Okay, I'm not solving it because it doesn't have what? An equal sign. Yeah.
Can we do 28?
Yeah. Okay. Is there an equal sign up here?
No.
No, so I'm not solving it. Do I have a greatest common factor that's a number? 3. Do all 3 terms have an x?
No.
No. So I can factor 3 out of each term. So all 3 of these has a 3 in common. We're going to rewrite it with that the 3. So that's 3xx. 3 times 3 times x. And that's plus, that's minus, and that's 3 times 40. Is that okay?
Yeah.
So then I have an x squared plus a 3x minus a 40. Agree? Is this part of the answer?
Yeah.
So we're going to bring it down and leave it alone for right now. I want to factor that now. So my magical number is negative 40. That means I multiply two numbers together to get a negative, so they have to be alternating signs. What factors of 40 would also add up to positive 3? 5 and 8? And it'd be a negative 5 and a positive 8. If I add those together, do I get positive 3? If I flip-flop it, I get a negative 3, so watch out. So then let's go ahead and bring it down. Okay, let me ask you this. Could I add plus 8x here and minus 5x there? Yeah, it's still going to be the same. What do I have in common here? X, and then x minus 5. This sign just comes down. What can I factor out of both of those? 8. So 3, x minus 5, x plus 8. Hey, if I flip-flop x plus 8 and x minus 5, is it still the same? If I flip-flop
Yeah.
So I could have had 3x plus 8, x minus 5 as well. That would work. Yeah.
So, at the top, like, you did 3x, like, the red at the very
Uh-huh,
top.
yeah.
So you did 3x plus 3 times 3x. So, what if it was like, okay, so what if it was like two different numbers? Is that?
Then they wouldn't have a numerical greatest common factor. So like if up on top we had 3xx and then say we had 5 times 2x, and then, I don't know, 7 times...
No, like, what if it was like 3, so, like, okay, what if it was like 3xx plus 3 times 4x plus 3 times 40? So 3 is in there, but...
So the 3 comes out of all of them. And then the second one would be a 4x, then if you had a 3, 4x.
So to get the, to choose that, it was, okay, I got it.
So what's basically taking place is this right here is kind of indicating what I hopefully I could factor out. It doesn't always have to be, but that's where I'm looking. I can't factor a number out of something that if that number wasn't part of that portion of the equation.
Okay.
What else? What else? Yeah.
Can we do 16?
16.
I have a video. Someone, they watch it. But I don't think so.
Okay. So this says, in the following equations, use the zero product property to determine the roots of the equation.
There is.
So this is already a factored version. I don't have to multiply it back together. And we're solving. We're trying to figure out what x can equal to give me 0. Okay? So I'm going to take each set of binomials and set those equal to 0. So I'm going to set this equal to 0. And then I'm going to set this equal to 0. Okay? So this, if I solve this, add 3 to both sides, so I get 3. There's one answer. And then if I solve this, subtract 14, divide by 2. So there's my 2 answers. The reason I get my 2 answers is I have an equal sign on this one. What else? More comfortable? If you would, make sure your name is on that, please, and pass that forward. And if you're handing anything else in, you can hand that forward. Just make sure your name's on everything. Make sure your name's on that one. Jay. Make sure your name's on that. Backpack's still out there.
You do one letter one? Yeah.
All right, pretty short notes today, which is nice. That just means we don't have a lot to cover.
What is this class mean?
Math class.
Did she get one on hers?
No, because she's not here.
Oh, it's the girl behind you, though?
She hasn't.
Cool. Yay. All right, let's take a look at these notes.
Small ones.
So equal sign means we're trying to take the factored parts and set them equal to 0, right? So let's warm up. Let's solve these. These all have equal signs, so I'm going to factor them first and then set each of the factors equal to 0. Is that okay? So this one, our magical number is -6. So I have positive, negative. Which values of -6 multiply to give me negative 6, and add to give me negative 5.
3 times 2.
3 and 2, I do agree that will give you 6, but if they were both not negative, they don't give me negative 5. And I have one positive, one negative. What else works on 6?
1 and 6.
1 and 6, definitely. I got 1 and 6. The 6 is going to be our negative. So I have x squared plus 1x minus 6x minus 6. Agree? Then let's factor that. That sign has to come down, so I'm factoring a negative 6 out of both of those. So that gives me x plus 1 and x minus 6. If you get to that point, you factored it. But this has a equal sign, so we solve each. There you go, x plus 1 equals 0, and x minus 6 equals 0. So I get negative 1, and I get x equals 6. So sometimes you can go from here to here, which I think most of you can do. Okay, so you don't necessarily have to show the x plus 1. The time you have to show that last step is like if you had 2x plus 6 or something like that, then you solve that. Second one, it's already in factored form. This is already factored. So I'm going to say, well, x equals 0 and x minus 5 equals 0. And there's my two answers there. Because that was already in factored form, we didn't have to break it down. If this wasn't in factored form, this would look like this. And then you'd have to factor out a GCF of x. Okay, number 3, we're factoring it, right? What can come out of all three of those terms? Don't include the 0 though. 2. Does everyone agree with 2? The reason we can't use 4 is 4 doesn't go into 26 and 4 also doesn't go into 30, right? So let's factor this. Yeah, thank you. Do you agree with that so far? Okay. And remember, this is still equal to 0. Put a 0 in there. So there's really nothing I can do here. I mean, I can bring it down and say, okay, it'll factor. So let's factor this part. My magic number is positive 30. I get a positive 30. So when we multiply two numbers to get a positive, they can both be positive and they can also both be negative when multiplying them. So are these both positive or both negative? Both negative? They're both negative because of that. Okay? So they're both negative. So what factors of 30, both being negative, when I combine them together, give me negative 13? Yo, what's up, bub? Sure. I didn't sign yours already?
No.
What do you want to do?
I don't know.
Senior year, you want to do college algebra and stats?
Sure.
Okay. They're both semester courses.
Alright. Do I need anything else from school?
No, they'll satisfy between the two of them. They'll cover a year's worth. Cool. Yeah, I might be teaching stats, so
Oh, yeah.
you might have me again for a semester.
Excuse me. They fall?
What?
They fall out?
No.
Okay. This one.
10 and 3?
Just embarrassed me in front of a junior. What the frick, man?
Oh, is he a cute one too?
No.
Oh, okay. I'll let him know. All right. Everyone agree 10 and 3? If they're both negative, if I add them together, I get negative 13. So they're both negative. So then I have 2x squared minus 10x minus 3x plus 15. Squeeze. Squeeze 15. There we go. Squeeze the trigger.
Stop.
All right. So that's going to give me 2x and x minus 5
That's not funny.
minus 3 and x minus 5. So this comes down to 2x minus 3 and x minus 5. this 2 out here, does it have a 0? Or, excuse me, does it have an x?
Yeah.
Yeah.
That 2 outside, does it have an x?
Well, no.
No.
Like once it multiplies.
But this has how many solutions?
1.
2, because it's raised to the second power. So I'm gonna take this, set that equal to 0. Take that, set that equal to 0. So that's 2x equals 3, x equals 3 over 2, and that's x equals 5. Agree? Seem okay? What happened to that 2? We just kind of ignore it as the greatest common factor because it didn't have an x attached to it. If I factored a 2x out, though, then we'd have a third 0 being x equals 0, or a third root. Okay? So, in those warm-ups, you use the zero product property. They had to equal each of the parts when it factored equal to 0, and then we solved it. Okay? Okay. So, problem number 1. Does it have an equal sign? Yes. So we're going to solve it. Got it? But it doesn't equal 0. So how would I move that -3 to the left side? Plus 3. Yeah. So you want it to equal 0. So I'm going to add 3 to both sides. Now it's equal to 0. You see what I just did? And if you factor it, you might get x minus 3, x minus 1. And those are equal to 0. So x equals 3. X equals 1. Done. I just didn't go through the long way to factor it.
Did you choose 3 because it equals 3?
It equaled 3, so I moved the 3 over by adding it. So I made it equal to 0. And then my magic number would have been 3 times the lead 1. So 3 is my magic number.
Oh.
So 3 and 1 both being negative would add to -4.
Okay, got it.
Problem number 2. Is it equal to 0? Is problem number 2 equal to 0?
No.
No. How would I move the 9x over?
Yeah.
What's the opposite of 9x?
Negative.
Subtract it. Negative 9x. So I'm going to get this. Is that okay? Can I factor an x out? So I get an x and x minus 9. So one of my answers is x equals 0. The other one is x equals 9. Done. Hey, is number 3 the same as number 1?
Yeah.
It is, so let's just skip it. Sound good? 3 and 1 are the same exact problem. Problem number 4. So we're just going to strike through that because we've already done that one. Problem number 4. Add 4. Do I have a greatest common factor?
Oh no, I missed it.
Do I have a greatest common factor? Do I have a greatest common factor?
No.
No.
You never see one.
What's my magic number?
8.
8. Positive 8.
I know.
In order to get a positive 8, I have to multiply 2 positives or 2 negatives. What is it? Both negative or both positive? Of course, I struck right through it. So it's both positive or both negative?
Oh, look at that 8.
Both negative? 8 and 1?
Look at that 8 I missed.
Okay, so I get 2x squared minus 8x minus 1x plus 4. Factor out of 2x. Some of you are chatting too much. X, that's a minus 4.
Hey.
Hey.
It's calculation.
And factor out -1 from here. So, x minus 4 and 2x minus 1. Set those both equal to 0. So I get x equals 4. What's the other answer? Add 1 and divide by 2. So 2x minus 1, that's going to give me x equals half. There's my two answers. I don't know, we didn't give you guys enough room on these. Silly us. What, talk to me about x squared minus 4. X squared minus 4. Does this factor? I'm going to say yes, but what kind of factoring is this?
X times negative 4 plus 0.
Is this the difference of two squares? Is x squared a perfect square? Yeah, because x times x is 4 a perfect square. Is this the difference of two squares?
Sure. Yeah.
It is. So it'll factor to what? X minus 2 and x plus 2. So my answers are positive 2 and negative 2. Cool. 6. Yeah.
Can it also be x equals 4 and x equals 0? Can't be.
Because this will break down. So difference of two squares looks like this.
No.
Okay. So these are all difference of two squares. So that's x plus 1, x minus 1. This is x plus 2, x minus 2. This is x plus 3 and x minus 3. So this is x plus 4, x minus 4. And this is x plus 5 and x minus 5. And if I had this, that one is prime. I can't factor it. So difference of two squares, subtracting two perfect squares works as long as your two are the square roots, adding and subtracting from each other. Okay? All right, what do I have in common on these? X. So one answer is x equals 0, the other answer is x equals 3. Done. Ew. Look at 7. 7's silly. Alright. I'm going to bring 7 down here. What did I do? Made it to 0, so I had to do the opposite of negative 20, which is positive 20, to move it over. I had to do the opposite of 32, which is negative 32, to move it over. Okay. Doesn't look like it can do a greatest common factor, does it? No, it might not work. Let's see. So my magical number is negative 96. So in order to get there, I need positive and negative. I gotta think of the factors of 96. This is where if you had a calculator, it'd be helpful. So I know 1 and 96. Well, that's not going to add up to 20. I know I have 2 and 48. And I know that's not going to equal 20. I know I have 3 and 32, and that's not going to give me 20. I have 4 and, let's see, 24. Ooh, 4 and 24, one being positive, one being negative. Does that work? Does that add up to the 20? Which one has to be positive? 20. So 3x plus 24x, and then minus 4x minus 32. Let's factor that. So I can factor 3x out. So that's x plus 8 minus x plus 8. So my answer, this is a tougher one. So you might see one about this tough on the test. I wouldn't say I would give you many like that on the test. So am I solving it? Was there an equal sign?
Yeah.
There was an equal sign. Thank you. So x equals -4. And let's see, add 4 to both sides. Divide by 3. Sometimes better work those out a little bit longer so you don't make a little sign error. Seem okay? Alright, and last one. I'll do this nice purple. This one right here, I'm going to kind of bring down over here to solve it. Do I have a greatest common factor? 6. And I have x squared plus 1 equals 0. Okay, is x a perfect square? Yeah, because x times x. Is 1 a perfect square? Yeah, because 1 times 1. Is this the difference of 2 squares? Difference means what? What does difference mean?
Not the same.
Okay. Difference in math though means sum means add, difference means
Opposite.
Oh my god.
negative. Okay, so are we adding these?
No.
Are they added?
Yes.
No, you're multiplying.
Is
No.
x squared plus 1, are those being added?
Yes.
So do we have the sum of 2 squares up there, or do we have the difference of 2 squares?
Sum.
We have the sum. Is there a way to factor the sum of 2 squares? Is there a way to factor the sum of 2 squares? Let me go to my very last slide that we did a whole bunch of different 2 squares on. That black one, x squared plus 25. What did we say the answer is?
Prime.
Prime.
So the answer
Oh,
is
so there is no difference.
Right, that's not,
Two
so
squares.
that one is not the difference of 2 squares.
prime.
So this one is prime.
Wait, so you can't solve?
Yeah, that won't break down. That doesn't break to x plus 1, x minus 1. It doesn't break down. Okay?
How do we know if it's the difference of 2 squares?
Subtraction sign.
If it's
If it was x squared minus 1, difference of 2 squares. Sum of 2 squares.
So it's because it's x squared and plus 6.
It's because you have x squared plus 1. That won't factor.
If that was a negative sign, it would be.
So I have a greatest common factor of 6, yes, but then I can't break it down any further.
Right.
So just so you know, this is your bonus.
Should we have homework?
Yeah. So, if I graphed this, it looks like this. This is the x-axis. Does this graph cross the x-axis? The answer is no. That means it won't factor. It's prime. All right, so your homework would be, what did I give you last time?
43.
So let's do 45 and 46 if you don't mind. Cool?
Yes.
All right. You got a few minutes to probably get 1 or 2 done.